Question 46, Electrical and Electronics Engineering, GATE 2015 Set 1. In a linear two-port network, when 10 volt is applied to port 1, a current of 4 ampere flows through the port 2 when it is short-circuited. Consider a two-port network. It has one input port and one output port. A voltage of 10 volt is applied at the input port, and through the short-circuited terminals of the output port, we have 4 ampere that's flowing. When a voltage of 5 volt is applied at the input port, a current of 1.25 ampere flows through this 1 ohm resistor connected to the port 2. What is asked is, in a similar fashion, when we apply 3 volt to the input port and we have a 2 ohm resistor at the output port, then what is the current that's flowing into the port 2? Let's have a look at the admittance parameters and solve this problem. Admittance is the reciprocal of impedance. The current I1 is equal to Y11V1 plus Y12V2, and the current I2 that flows into the output port is equal to Y21V1 plus Y22V2. Let's find out the value of I2 as required. In the first case, is given that V1 is equal to 10 volt and we are short circuiting the output port. So therefore V2 is equal to 0. I2 is equal to 4 ampere without any load. From this we can find out the admittance Y21. Y21 will be I2 divided by V1 when the output port is short circuited. This will make V2 to be 0. So the value of Y21 is equal to 4 ampere divided by 10 volt, which is equal to 0.4. From the second information, 5 volt is applied at port 1 and a current of 1.25 ampere flows through a 1 ohm resistor connected across the port 2. Therefore, the load is 1 ohm and the current I2 is 1.25 in this case when V1 is equal to 5 volt. Let's make use of the second equation for this. 1.25 is equal to Y21 into 5 volt plus Y22 into V2. V2 is equal to the current 1.25 into the resistance 1 ohm. Let's substitute the value of V21 from here. So therefore Y22 will be 1.25 minus 0.4 into 5 divided by 1.25. Y22 is equal to minus 0.6. We have found out the value of Y21 and Y22. Let's make use of both of them to find out the value of I2. In the third case, it is given that V1 is 3 volt and the load resistance is 2 ohm. So under this condition, we have to find out the current I2. V1 is 3 volt and the load resistance is equal to 2 ohm. We know that I2 is equal to Y21V1 plus Y22V2. So the current I2 is equal to 0.4 into 3 plus minus 0.6 into V2. V2 is I2 into the load resistance, which is 2 ohm. This implies that I2 plus 1.2 I2 is equal to 1.2. Therefore, the value of I2 is equal to 1.2 divided by 2.2, which is 0.545 ampere. Therefore, when 3 volt is applied at the input and we connect a resistor of 2 ohm, then a current of 0.545 ampere flows through the output port. The answer is 0.545 ampere.